Okay, so as I mentioned, this next one looks pretty, basic, but it's going to create some more problems. And again, we really have to understand what we're doing, both previous knowledge and whatnot. Again, as a reminder, what we're trying to do is find all the angle values in the first positive rotation from 0 to 360 degrees. So watch what happens when we try invoking technology here. So again, pretty easy, right? To solve for theta, I'm just basically going to make use of my inverse tangent function. All right, thinking ahead, where is tangent negative? All right, so this is basically a combination where x is positive and y is negative, right? Or where x is negative and y is positive, right? Well, that happens in quad 2 and it happens in quad 4. So that's where I'm expecting angle values to occur. And lo and behold, when I go to my technology, my little tool, and I type in the inverse tangent of -1 divided by 5, all right, what we do get is an answer, right? We get a -11, let's call that 31. So the technology is giving us a -11 and 31 degrees, all right? But here's the dilemma, right? This falls outside of the full rotation, right? We want the full positive rotation, and we're basically going through a negative rotation. And notice it in fact is giving us the angle in quad 4, but it's just the wrong sign. All right, so we have to kind of work around the limitations, if you would, of the technology. So again, wonderful tool, right? But if you don't really know what you're doing, right? If you don't have some previous understanding, then this is useless, right? But let's make use of what it gave us. So picture-wise, here's what we got, right? So we now know, right, that a rotation negatively of 11.31 degrees, right, that rotation gives us what we want. Even if I labeled it, right, this is a y over x, that would be 5 and -1 respectively. But the angle we're looking for, right, is this angle right here in red, that would go through a positive rotation and basically have the same reference angle of the angle that we found. So pretty easy, right? How do we find that angle? Let me call it theta for a moment. Well, that theta would basically be 360 minus the 1131 that we have. So we've got 360 minus 11.31, right? Press enter, and we get 348.69 degrees. All right, so again, obviously that occurs in quad 4, and it also falls within my first positive rotation. So far, so good. Everything is fine. As a matter of fact, easy to check, right? If I take the tangent of 348.69, right, press enter, what I get is about -0.20000, which is what -1/5 is, right? -1/5 is -0.2000. So it works. However, right, what else were we expecting? We were also expecting an answer in quad number 2. All right, and it's going to have the same sort of situation. This time, the reference angle, right, is going to be 11.31 in that quadrant, but as terms of my x's and y's, my x is now negative and my y is now positive, right? So 1 over -5 also gives us that. So for this angle, we are now looking at that, right? So that theta, right, is basically 180 minus the 1131 reference angle that we have. So again, reaching for my calculator, we got 180 minus 11.31. We enter, and we get a theta value of 168.69. All right, and again, that angle clearly falls within quad 2, right? And it also falls within the first positive rotation. So that, right, using our reference angle knowledge, using our knowledge of where we're expecting to be positive or negative, combined with what the technology gave us, gives us the full picture. So we're putting a lot of things together using the tool, right? But then expanding past what the tool is. This is limited, believe it or not. So there's your answers. Again, easy to check, right? I'll just take the tangent of 168.69, right? And again, that'll be really close to 0.2, negative 0.2, which it is, right? So we basically nailed it. Again, we're getting estimates because I estimated this. If I want more accuracy, give yourself more decimal accuracy. So there you have it. So that's how we find, again, the technology is going to give us a value, all right? Sometimes it's one I can work with, and then I can just use reference angles to find the other. And then at other times, it's going to give us something that doesn't quite give us what we want, but it is useful information. It gives us, and if anything, it gives us a reference angle, or at least ways to find the reference angle that we need so that I can find other values, right, in a full rotation. Why the inverse functions do what they do is going to become more clear when we take a closer look at them later. I believe it's chapter 3 or 4, somewhere in there. We'll take or 5 maybe even. We'll take a closer look on why the trig functions behaved. Why did it behave nicely in one case, right? Why did it behave kind of nice in another, and then really kind of bog us down a little bit in this one. That story will become clear as we learn more, but hopefully that gave you a pretty good idea how we're going to solve this using technology with our knowledge of trig. All right, so that should wrap that up. Get on that quiz, ask for help if you need it, and I'll talk with you guys later.